Okay, good morning everyone. Another educational talk by Barco. Today we will talk about color calibration of medical display systems. So my name is Tom Kinkel. I'm responsible for technology and innovation at Barco. As you all know, color images in medical imaging has really become widespread already. And it's used in a number of modalities, a wide variety of clinical applications. You see a few over there, for example, dermatology, you see sonography, you see some MR images, and you also see PET-CT imaging on the right. Very often, color imaging is actually combined with grayscale imaging. So you have a basic grayscale image, for example, CT image, and then you have another modality, the PET, which is going to add additional information that is being shown as a color on top of the grayscale image. So, what about calibration? So, everybody knows DICOM calibration, DICOM GSDF calibration. Well, this does actually not cover color. So, DICOM is not at all going to do anything on calibrating or safeguarding consistency of color appearance. So, if you're not doing anything special, if you don't take any additional steps, then if you just calibrate the display to DICOM, you will still have a large variability and fluctuation of the color characteristics. Moreover, your color will not be perceptually linear. So it means that some color differences will actually be much larger or smaller than other ones. You can see that very well here in this color ramp, where you hardly can see any differences in the green, you hardly see anything in the blue, and then there are huge steps going from one color to another. So that's not what you want. You want to equally be able to see all different, I'm not going to say shades of gray, but color tints that are available and are being used in medical images. Let me take you a step back to very briefly explain how grayscale calibration is done, because we will need that then to explain how we solve the color calibration problem. So DICOM GSDF has been used already for a very long time. It's an industry standard. It's also in regulations worldwide. So in fact, every medical display is being calibrated to DICOM GSDF. It's important to understand that this is not an absolute target curve. It's really aiming at perceptual linearization of grayscale. So it means that you will maximize the number of visible gray levels on a display, making them perceptually linear, but not reducing brightness or contrast of the display. So you use the maximum capabilities while calibrating to the DICOM target curve. And in practice, it looks like something like this. So what you're going to do is putting those shades of gray on the target curve. So that's grayscale calibration. What about color? Well, Barco is a leader in medical imaging. We're an innovator. So quite a few years ago, we realized that this was a problem, and we actually started working on extending the DICOM GSDF curves to also include color. So we proactively did research, we worked with key opinion leaders, we worked with regulators and so on, and we made a proposal to extend and include also color. So we called it the CSDF, the Color Standard Display Function. And the way that the way it works is the following. This is your color cube of a display system. So you have your primary colors, red, green, and blue. And what we're going to do is we will shuffle all those colors in that cube in such a way we will replace them, we will put them at other positions such that the differences perceived between the colors become the same. So we will perceptually linearize, in fact, the entire color cube. So you can do that, but there are a few boundary conditions that you need to respect. And the boundary conditions they are listed here. First of all, you should not change anything to your grayscale behavior, because that still needs to be GSDF calibrated. You don't want to change the appearance of the X-ray images or CT images while optimizing your color behavior. It's really both you need. You need an accurate grayscale representation and a good color representation. Also, you do not want to reduce your display luminance or contrast when changing your color behavior. You don't want to create a dim display because you're optimizing color. You don't want to reduce the contrast. Also, you don't want to reduce your color gamut. So if you have a high quality medical display, like you can see on the boot here, with vivid saturated colors, yeah, you want to keep that. You're not going to make it a less saturated display. And finally, you also do not want to change the appearance completely. If something looks reddish before calibration, it still should look reddish after calibration. You don't want to make it a totally, completely different color. So practically, the way we do that is by, we start from the native behavior of the display system. Take, for example, the green line in the color gamut, so going from black to fully green. If it's not calibrated, that's what you have here. And you see that the distance between the consecutive shades of green is not the same. So it's not perceptually here. So if you do CSDF calibration, you're going to redistribute those points on the green axis such that they all are equidistantly placed. And you do that also for the other primary colors, and you do that also for the secondary colors. So in a very simple way, that's how you can do CSDF calibration. So again, why these boundary conditions? Well, it's because I briefly mentioned it already, but you can't change your compliance of grayscale, which is crucial. This is a given that you need to do. And then, of course, you don't want to reduce luminance, contrast, and color gamut of the display system. A little bit more details for the people that are interested. As a perceptual linear metric for color, we use delta E2000. It's a state-of-the-art metric. It's maybe not the best one. There exist many different color methods, but it's the standard. It's something which is widely accepted and which actually works quite well. Okay, so we can calibrate, but can you also quantify? Can you actually show how well something is calibrated to CSDF? Well, yes, and again, here we looked at how it's being done in grayscale calibration, and we extended that to color. So what you can see here is two types of graphs which are very useful to quantify how well perceptually linearized a color display is. The one on the left here shows the delta E2000 step per color line step you take. So if you go from one red shade to the next one, it shows how big the difference is between the consecutive ones. And as you can see, it's before calibration absolutely not a constant. What you do there is perceptual linearity, so it's the same information, but you divide it by the steps. Actually, this is really nice. So we also created a test pattern, which Barco also included in its QA Web quality assurance software. If your display is properly calibrated to CSDF, then you should be able to see all the targets in this pattern. Here you hardly see any. So from where I am, you can see a Barco logo in the red. I don't see anything in the blue, and I see, if I really look in detail, I see a little bit in the green as well. So very easy way to quickly, in a visual way, see is it properly calibrated or not. So if the display is properly calibrated, you should be seeing all those labels, all those targets, and all the colors. Let's make it a little bit practical. So if you have, for example, a display system for 100 candela per square meter, a typical contrast radiology display, which is GSDF calibrated, and you apply CSDF calibration, then something like this happens. So left side is before calibration, right side is, the bottom part is after calibration. So top part before and bottom part after calibration. So you can see that this is clearly not flat before calibration, so no good. After calibration, you almost get it perfect. Very similar to what you have with grayscale calibration. This is a photograph that I took of a real display system where the right half was calibrated, the left half was not calibrated. And you can see on the left half, nothing visible. On the right half, you see the targets. Well, of course, we're looking on a lot of display here, so hey, that's the reason why you do not see all of them. So what about the clinical relevance of this? So why do we do this? Does it really make a difference in in a real clinical practice, yes or no. But let's take an example of a PET-CT image of a mouse, PET-CT preclinical image. So there are a number of things that you can observe here. First of all, if you look to the color scales, you have the same problem that I indicated in the beginning. There is hardly any differences visible in the color scales. So you have, you see one blob of red, one blob of green, and then blue, but no real small differences. If you look here after calibration, you can clearly appreciate that you see much more different colors. So that's already one thing you can see, but it becomes particularly interesting if you compare the so non-calibrated versus calibrated image. For example, look to this part. Here you have much more detail which is visible in your PET image. On the left side you hardly see anything, it's all the same green, and then you have a few red blobs, but here you appreciate really the subtle information which is present in the PET image. If I zoom in, you also see that here. So without calibration, yeah, this looks all the same, but in reality it's not the same. So there is information present that you do not see. And this can be clinically very relevant because typically if you use PET tracers, it's to get a good imaging of a tumor, for example. So in this case, seeing the tumor margin is very hard. There you get much more information on the shape and the size of the tumor. Okay, so do you need to do all these measurements manually? No, of course not. So I told you Barco is an innovator. We've proactively thought out this, we've lobbied, we've worked with standardization committees. And of course, we also have implemented this technology in our own display system. So if you have Barco displays, you will find this back under the name Steady Color. So Steady Color is the implementation that Barco did of the color standard display function. And you also find back the logo that we use for that on the top right. Okay, concluding, so be aware, color is used a lot, you know that. DICOM GSDF calibration is not going to help you with calibrating color or having QA of color. So if you don't do anything, you'll be having issues with the color representation. You will not see all the colors. Some colors will be more easily visible than others, and certainly it's not going to be perceptually linear. So if you have ramps, color ramps that you use, color scales, yeah, some differences will be very large, other ones will be hardly perceivable. Perceptually linear color behavior is important, specifically in the detection task and qualification tasks. So Barco has taken the initiative to standardize an extension of the GSDF, and we've been implementing this in most of our display systems. Okay, I think I'm at the end. If you need more information, we also published this in a medical physics paper. You have the link here. There's much more details, much more technical explanation, much more graphs and measurements. So that's a good starting point if you would like to have more information. Thank you very much. I hope that you enjoyed it. That is my contact information if you need more, if you want to ask me further questions. Thank you.